I'm Ronald.
I'm Duran.
Why is reflection, why did it become a thing? What was the purpose for it? Why was it used? Because it seems to me that it could be this is, as we know, it can become an issue, but it seems to me that from some programmers, they like it better to be able to do things without actually writing a lot of code as well. And to call different objects or different stuff. I don't know, maybe I'm wrong, but that's what I've seen in a lot of forums and different things that people were saying. But I find it the lazy man's way of doing things. And that was one of the number one thing. But why did reflection become a thing? And why is it a thing? And why is it first, why is it a thing? Why is it something that people should be using, or programmers or developers should be using? And why is it a big deal? And big deal as far as for an attacker to exploit this issue if you do it the wrong way, unsafe.
Reflection is required for any serialization and deserialization to work. In fact, this is something a lot of people probably don't know or realize. Every single marshaller, unmarshaller, serializer, deserializer, whatever you want to call it, uses reflection. They use reflection on the back end. And just to emphasize the point, when we look at struts.xml in this example, and it doesn't matter if you're using struts, it doesn't matter if you're using C#, it doesn't matter if you're using Perl, Python, PHP, etc. They're all actually using reflection.
Okay.
What is happening is, you see how we have the class here, and then the method? It uses reflection. This is why my actions have to have a default constructor. And actually, we'll get into it more when we actually do our attack, and we'll explain some interesting and important things to understand about abusing reflection. But most of the time when people implement reflection, they assume that you have the default constructor. That is why it doesn't matter if you're using C# or if you're using the struts JSON plugin, or if you're using struts or what have you, and you're trying to stuff data into your action layer and into the VOs and all of the corresponding objects, they always have to have that default constructor, because these things go through, they use reflection to instantiate the class, and then they pull all the methods and all the fields that are public that they can access, and they use that to set the variables. It's also why you have to give specific names, or it won't set the variable, or it won't get the variable when it's doing the serialization. So it won't actually retrieve that variable's data and send it on its way. The other way you'll see it done is, for example, you may have noticed we have this @JSON property, so we're using annotations. Annotations operate using reflection too. Reflection is absolutely vital for us to do any serialization and deserialization. You cannot serialize and deserialize without reflection.
Okay. Makes sense.
By the way, when you use the binary formatter in C#, for example, so we're not even talking about doing something like JSON, etc. Or if you're in Java and you serialize an object, both actually do reflection. That's how they serialize the object. Every serializer uses reflection. And that's why when you look at that bytecode, you see the actual, similar to what we see here, you actually see that class for whatever the variable happens to be.
Okay. So that's why you would see that code when you're actually when you're trying to serialize, or when you're like say I have something encoded and I see the serialized payload, and it'll have the class in there. So that's that's utilizing reflection, right?
Yes, exactly.
So then in that case, you would have, and most people probably don't know this, or maybe it is, but in that case, if you have something that's insecure, that has insecure deserialization, which that also follow up by maybe also having unsafe reflection as well.
Correct. That's exactly right. That's spot on. In fact, when you see people attack the parser, so why so serial, for example, and then of course the corresponding C# version of it, both are actually not abusing insecure deserialization so much as they are abusing insecure reflection or unbound reflection. People don't recognize that because they don't understand the way these serializers and deserializers work. We actually showed how you truly attack insecure deserialization in multiple ways without attacking the parser. But when what they're doing is this reflection, when they're abusing reflection, that's attacking the parser. That's not actually attacking the application. And that's not really true insecure deserialization. Most people don't understand deserialization enough to understand what's really going on and to understand that, hey, when I go through and let's say we're talking about a JSON serializer and deserializer where it has the type, right? Well, if I change the type to something else, I'm creating a new object of that type that's actually not insecure deserialization. That is quite literally attacking via reflection, not via deserialization. Deserialization is merely your pathway to attack.
Okay. So then they're just probably getting it wrong on what the actual vulnerability is.
Yes.
Okay. So yeah. And that's a good note because a lot of people don't know that. And then you also don't actually see this information online. This stuff that you're seeing, you're not going to see online. Trust me, I've tried, I've looked, and there's not a lot of information, especially about unsafe or unbound reflection. And then when you kind of look at these things, people are thinking that it's insecure deserialization, but they don't actually know what the actual vulnerability is. And then it's kind of crazy because developers kind of get confused because they know their code, but they might not understand what the penetration tester or consulting is actually talking about.
Right.
So this is a good thing for people to understand. So this is awesome.
Most developers don't understand serialization and deserialization. That's all black magic to them, just like it's black magic to most security professionals. And until you actually delve into it and really get familiar with how each and every one of these things works, this is part of the reason why I say you in security can't become a hyper focused, hyper specialized security professional. It's just not possible. When you do that, it causes you to not understand things. The official description of insecure deserialization from organizations like OWASP is completely wrong. And the examples that they give are completely wrong. Why So Serial is not actually attacking insecure deserialization so much as it's attacking insecure reflection or unbounded, unsafe reflection. But if you don't understand the way serialization works, it makes sense that you'd sit there and you'd say, oh, okay, well, if you're including the type and I can change the type, and now since I can change the type, I can specify the method within that. And since I can specify the method, I'm now specifying the application's pathway. Therefore, it's insecure deserialization. Serialization was merely the vessel. It would be like going through and saying HTTP is insecure because I can send cross-site scripting requests. Well, it's not HTTP's fault. HTTP is merely the vessel through which you are executing your attack. We've already gone over the struts.xml in previous editions. I'm going to just go around that and say we've created a new action. This action is called by hitting API/reflect. Thought that was rather funny.
Yes, it is.
So this is the new reflective action. Reflective action, as we see here, takes in a single variable called action. It outputs a single variable called results. Action is what we are going to call. So action is a VO that contains the class name, the namespace, and various other characteristics tied to the reflection. So what method are we going to call? What constructor, if anything, are we going to call? And of course, what class are we going to scan and then wind up pulling from? Results, merely the results that come back from our reflective call. There's nothing to write home about with regard to any of these particular methods. I will note here that we've restricted them, allegedly, using the JSON property. We've restricted that read and write access. Now, if you remember, if you haven't seen our episode on insecure deserialization, you'll note that we show how you can actually bypass things like this based on the different serializers. So while something may deserialize by default in JSON, or they may push you to use JSON, there might actually be other deserializers that you can use. In the case of struts, there's always the default struts deserializer. So I can actually completely bypass the JSON deserializer by instead using the struts deserializer, which lets me bypass a lot of these kinds of things. And similarly, we talked about how you can use the fact that there are the two to bypass the struts protections, for example, and we were able to set session record and create our own session, even though that should have been blocked, because according to the struts deserializer, it was configured to block anything that has the word session in it. That's just important to note, because the more deserializers you have, the more vulnerabilities. It's all about surface of attack, and we talk about that in our threat modeling, but it's an absolutely positively important thing to recognize. You have the same exact issues when we talk C#. There is a default deserializer, PHP, Perl, Python, so on and so forth. All of that aside, because it's not really the main topic of this particular one, this action only allows index calls. The difference between show and index is show has an ID. This one, it doesn't matter if you put in an ID or not. It's always an index, meaning all you will do is API reflect, and then you put in whatever your reflection VO values happen to be. Reflection VO really quickly goes through. It has class name. It can take in constructor parameters. It takes in a method name, a namespace, and then any parameters. Now, parameters here, these are the parameters to pass to the method, versus constructor parameters are the parameters to pass to the constructor. In our case, we made it a little bit more versatile than what you'll normally see in some ways, and less versatile in others. We actually allow you to select the constructor. And the way we do that, you have to understand the way reflection works. But when we go through and we make a call to index right here. So index calls the reflective BLO gateway, calling reflectively call method. If you look at this, all it does is make sure that the action isn't empty, meaning that you actually provided one. If you provided an action, then we go here to reflective BLO. Reflective BLO is actually much more simple than it seems. The first thing that we do is we pull up that class. And this is all reflection everywhere. So you see us go through and we do class.forName. And in this case, we concatenate namespace and class name. Most code will do something like this. They may not specify namespace. If they just have class name, then you can put the namespace in there. And we'll demonstrate that as part of the attack. If you choose to separate the two, great, separate the two. It's not going to make an actual difference in the attack. So after whatever your language is, pulls the class. So it has to load the class. Once it has loaded the class, now you grab what method you want, or you grab all methods, depending on how you're doing the reflection. You can grab all methods and then march through them. This is how a lot of the deserializers and serializers work. They grab all methods and then they'll strain them out. And they'll strain them out maybe through annotations or through modifiers, things of that nature. Ours goes through and it grabs that method, based on the method name, but it can do it one of two different ways. If you don't provide method parameters, it just gets that empty method, meaning a method that we expect to take in nothing. If you do provide parameters, it takes all of those parameters, and that's part of that declared method. And if this doesn't make sense to you now, we'll explain it more as we actually do the attack. It'll make a little more sense then. We go through, we get our method. Once we've selected the method, because remember, methods can be overloaded. So I can have a dot size that takes in nothing, and I can have a dot size that takes in an integer, and a dot size that takes in a long, and a dot size that takes in this, that, maybe it takes in two parameters, whatever it happens to be. This is how we actually select which of those versions of that method you want, is by providing the parameters. And when we do this, we have to do it based on their class, based on the object type. The last piece, so once we've grabbed and loaded our class, and once we've figured out what method we're going to call, we need to actually instantiate the class if the method isn't static. And then we have to invoke that method. So we select the class, we select the method, we figure out if that method is static. If the method is static, we don't need to instantiate the class. And that's what we have here. Because, of course, static methods don't rely on the state of the instance. That's important because that allows us to bypass the lack of a default constructor or any constructor at all that we can actually access. And we'll go into that as we do our attacks. If it's a method that is a class method, so it's non-static, what we wind up doing is we first have to instantiate that class, that object. And that's why we have to, if you provided constructor parameters, we use that to select which constructor to call, just the same as how we selected which method to call. This one here uses the default constructor. And we see that, so get constructor, this gets the default constructor, and then we call a new instance. Whereas this one gets the constructor based on the parameters, the constructor parameters, and then it creates its new instance right here. Oops. Then it creates its new instance right here using that data. And then we invoke the method or invoke the method here, or of course, like we did back here. So invoking is where we actually call that method. So again, real quickly, 3 ways. If it's static, all we do is we load the class, find the method, invoke the method. If it's not static, we load the class, find the method, and then we have to figure out if we're using the default constructor. If we are using the default constructor, we load the default constructor, and then we invoke the method. If we aren't using the default constructor, we find the constructor, load the constructor, invoke it so that it creates a new instance, and then we can invoke the method. So the first thing we have to do with the super vulnerable Java application, of course, is authenticate. And we've shown you can bypass authentication using insecure deserialization. I'm going to take this now. Here's my super vulnerable Java application /API/reflect. I put in my nice new cookie. And we see here, action, class name. You'll notice we aren't using the namespace here. So class name java.util.regex.matcher. So when we go here, this is the Java API for Java 11, remembering that we're working in Java 11. If you're using a more up-to-date version, you can go to that API and you would have all of that functionality as a result available to you. So let's say your Tomcat were running with Java 17, Java 18, what have you. You would actually be able to call to the new classes and new methods in that new way and get access to them. But, so keeping in mind what we've already said, we are calling to this. So the first thing that's going to happen is the super vulnerable Java application is going to find this class, and it exists. And then the next thing it's going to do when we look at our payload, we have to find the quote replacement method. and we actually have this quote replacement method, it's right here. You'll notice it's static and it expects a string. Since it's static, I don't care whether or not matcher has a default constructor. And you'll notice it actually doesn't. There are no constructors at all for matcher. That's not how matcher's created. Matcher's actually created via pattern. Pattern allows you to then build a matcher as a matcher factory. Since I cannot build a matcher using a constructor, the only thing I can call are static methods. And we'll see what happens when I try to call something that isn't a static method.
So if it was if it wasn't a static method, then you would need to call the default constructor in order to run this.
Or another constructor. And that constructor has to be public. In fact, actually, all of these methods have to be public. Unless in your reflection, you actually override Java's security or C# security or whomever's security to allow you to call a non-public method. And you, as the person writing this code, can very well do that. You can actually ignore the fact that something is private.
Yeah, if I were writing it, yep.
And you can also ignore things like final or const if you're in C#. You can actually go through, that's the beauty of reflection. Reflection lets you completely, utterly, totally circumvent all security mechanisms. But I, as the attacker, I didn't write this code. And so unless there's some way for me to, for example, drop a malicious reflective class or something like that on this thing, I can only deal with what's been given to me as an attacker. So in this particular case, I need a public method, and I need either that public method to be static, or I need some kind of public constructor that I can call. Just in this particular implementation. We may make another version where it allows you to call private constructors, allows you to call private methods, just so that you all can play with it. But the truth is, it's probably more beneficial if you, the viewer, were to modify the reflective BLO to add in that capability. That'll help you to better understand how to attack this and what to know and what to see. So in this particular case, I'm giving it a parameter path, and I'll tell you this parameter name means nothing, because when we do the reflection, if you actually read what we have here, and this is always the case, when we do reflection, it doesn't know what the parameter is called. It just knows the order. What matters is the order. So we expect to get a string, and here's my string here. So when we call this, we get our actual results come back, and you'll notice this is exactly what I would have expected a call to matcher's quote replacement with this given data to return. And just to emphasize the point that this doesn't matter, what that name is doesn't matter, we see again the same exact thing. If I were calling a method that had a whole bunch of different things, then I would expect something different to happen. So let's take a look at another fun one, maybe. So let's try taking a peek at java.net.server-socket and see what happens here. So I look at this one and I see it has a default constructor, but it has 3 other constructors that I can call to. It has one that takes an int, one that takes 2 ints, one that takes 2 ints, and then a net address. Now understand, I have to work with the deserializers available to me, and we'll see what happens with that. So let's go through. We're going to change our payload here, and we're just picking the Java ones right now just to show you some of the functionality. And I'm actually going to move this out into that namespace just for fun. So here's my namespace variable. Now I've set that, and we need to give it something. So let's try giving it a method accept. And we note that this doesn't take any parameters. So we remove this. So no parameters now. When I call this, result gives me an empty string. So I didn't get back the socket. And you may ask, well, why didn't I get back the socket? The answer is actually going to be in the logs. And it's actually really interesting. Okay, so this one failed because the socket isn't bound yet. The reason why the socket isn't bound yet, because of course we didn't give it a port, or a port with the backlog, or a port with the backlog and address, a bind address.
What are you doing, man?
So what this tells us, that's right. So now we're going to exploit the fact that we can pass in constructor arguments. So let's go through and we're going to say constructor. And we'll give it constructor parameters. And again, the name of this doesn't matter. Just to prove the point, we'll have it like this. And let's give it 1, 2, 3, 4, 5. And we're going to see something funny happen here. And this is because we are bound by the deserializer. So when we look at this, what we're going to find is could not find a class server socket with the method accept. And we know that method exists because when we look at this here, this is telling us that the constructor server socket java.lang.long doesn't exist. The reason being, our JSON deserializer by default is deserializing this as a long, an object long. If instead I were to put it up here and we do action dot like this, we're now going to be using a different deserializer. Now we're using the struts deserializer. And what we'll see is the struts deserializer may or may not do it the same exact way. So I have options here because again, if I'm going after the struts parser versus struts JSON parser versus, the C# parser versus a random JSON, say json.org's parser, what have you, I can actually change this content type and then shift to a different parser. So if I don't like the results I get, if I don't like the fact that the struts JSON parser by default is making this a long, and that's preventing me from calling the method that I want, in this case, server socket that's actually bound, then I switch my parser and try that parser. And I don't need to change the code. I just have to change the request to queue up a different parser if they have those other parsers. And that's really important. You have to understand how to maneuver between the parsers and actually abuse the fact that they operate differently. But I'll give you a fun one just to move off of this. Let's try toString. So we see there is, in fact, a toString method here, and it's going to work. So it's actually created an unbound server socket, and then it returns the string value of that, which of course is server socket unbound. So we know that we're actually creating server sockets. The only thing that we have to do is get around the very minor, very trivial issue of that type. And we're actually going to leave that as an exercise to you, the audience, because we're going to do something else that's maybe a little more interesting. Let's examine the general structure that you see across all of our systems. So we notice here that we have a public class reflective BLO gateway. We notice that these public classes have methods that are static, and everything is static. And that typically, not in this particular one, but in most of these, we wind up having the default constructor be private. To give you a good example, we have our private default constructor in common DAO. Common DAO is also a default class. So I couldn't call this via the unsafe reflection, the unbound reflection, the way it's currently written in this application, because it's not overriding the fact that the class isn't public. It's not overriding the fact that the constructor isn't public. But what I can do, let's take a peek at the DAO gateway. So the DAO gateway right here, let's actually call it. So to call this, we look at our package. This, of course, is going to be that first half. I put in my package, just like this. And now I'm going to put in the actual class name here, just like this. And we have to select a method. Now remember, the way our reflection works, if it is static, we don't instantiate. What that winds up meaning is I can select any one of these and I can actually call to that particular method. Or if we were looking at, say, the database manager, we could select database manager, just like this. And database manager, just like the others, we have this private default constructor and we have no other constructors that can be called. So there's no way that someone is going to be able to instantiate this. And what we instead do is we're going to abuse the fact that we have these static methods. So let's pick a fun one. We could call Git Builder. So let's call Git Builder. Now Git Builder takes in 0 parameters, but we do have another one that takes in a connection. So hypothetically, if you could find a deserializer where you can pump in a connection and it will deserialize that connection, then you'll be fine. So if connection itself, which it isn't built that way, but if connection itself were serializable and deserializable, then I could use that method. It's not, so that's a moot point. But I'm going to call Git Builder, and this is going to return a 400. The reason why this returns a 400 is quite simple. When we look in the logs, we see here, undefined. So Jackson couldn't deserialize the results. So remember, results takes an object. That's what's sitting inside of our action. When we look at reflection action has this result. So it's just taking whatever comes back from the reflection and it's mirroring back. I'm calling to the method. It is doing everything with this Git Builder. It's doing everything that it's supposed to, but it isn't returning something. And that means that all of the code within that method actually gets executed. Here we're going to call to get UID, which returns our user ID. And you see here, this actually happens to be the user ID of the user. So just to point out, this works perfectly, even though this is a class that can't be instantiated. So how would we fix this? If we were actually trying to maybe make this code so it weren't vulnerable to someone using our statics against us, we comment this out. So no longer is it going to sit there and say, hey, it's static, therefore I don't need to instantiate it. Now it's going to try to instantiate. And when we build this, and what we're going to see is our method hitting the database manager get UID, which just worked, will no longer work. And the reason why it will no longer work is, again, obvious once we look in the logs. And we see right here, could not find the database manager class with the method get UID. We know it knows where that method is. The real problem happened, as we see right here, with the get constructor when it tried to call that default constructor, but the default constructor is private. Since we didn't override that, now an attacker can't call a static method in a class that doesn't have a public constructor. Whereas if we go back to that default behavior right here, they can. And this again allows those attackers to call any method anywhere that they want. And we'll give an example. And this kind of abuses the same thing that we already showed when we did the insecure deserialization one. We demonstrated this, but we demonstrated it not by attacking reflection. We demonstrated it by attacking the unfettered deserialization, how it recursively deserializes. And what we're going to do now is we're looking at this file VO, and we're actually going to call a setter. We could call set contents if we use the default struts serializer. We could call set contents and actually set the contents of this, because I can pass bytecode. Passing bytecode through the JSON deserializer is a little more involved, so we're going to ignore that. But I've got this set file. So first thing I'm going to do, change this. We know set file takes in some parameters. Put this in quotes because it's a nice thing to do. Again, we don't care what this thing is called, so right, like this. And it's going to take in a string. So let's do Etsy password, just like this. Now we have to, of course, put in this data, our namespace. I don't know why I didn't just change this to .vo. And then we change this to file VO. I log in. It always takes a while the first time. There we go. Just because struts actually has to initialize the action. We call this. And here are the file contents, and that, of course, is Etsy password. So again, the beauty of this is we can call anything. And I will point out there are a lot of very dangerous methods sitting inside of the Java code, the Java library itself. So we look at file output stream, for example. And if you want a real fun one, we'll notice file output stream here is auto-closable. So let's be lazy. I'm going to copy this. I'm going to put it in. I'm going to be really lazy and just put it right in here. And what do we want to do? So file output stream requires a constructor that is non-default. So we have to put in our constructor parameters. Like this. Again, the name doesn't matter. And let's say /temp. Oops. Temp. And we'll give it this name. And we could call really a number of methods like the write and then just pass in the byte stream. But we're going to be good little boys and girls, and we'll just call close. All right, so that doesn't return anything. The reason why it doesn't return anything, of course, is because this method is void. So the real question is, was this class, was this file written to? And the answer is yes. We can see Tomcat created this file. We didn't pump any data into it, so nothing was written, but it made this file just now. And we could, of course, use this reflection to call a method and call another method and so on and so forth. So again, the point is with this unsafe reflection, unbound reflection, insecure reflection, whatever you want to call it, attackers actually get access to call any public method inside of any class with a default public constructor, period. But on top of that, depending on how you've configured your reflection, they can actually call even more than that. They can call static methods without you having a constructor that they can call to. They can call non-default constructors if you gave them the ability to do so, so on and so forth. And as a result, they can execute almost any code, period. And they may have to do it, for example, in our case, through these gateways, because maybe they can't hit the inner classes, but by attacking the gateway, by hitting the DAO gateway, for example, in our code, you would actually be bypassing all of the permissions checks that are done in the BLO for reading files, reading projects, writing to projects, and all of that kind of stuff. So it allows an attacker to bypass arbitrary code and call arbitrary code. And this is the real reason why reflection, while required, is insanely dangerous, ridiculously dangerous. And like I said, every single serializer and deserializer uses it. And in fact, that means that ASP.NET, it's built into it. Struts, it's built into it. And there's no way you can get around that. The only thing you can do is try to make sure that you use serializers that don't allow someone to specify the type.
If you like this, please comment down below for more episodes like this one. And that it concludes our session. I'm Raniel.
I'm Duran.
And like, comment, and subscribe for more episodes like this one.
Have fun.
Next time.